Shanti Chellaya, and in this lecture I am going to discuss on Unit 3, which is PLL and its applications. Next, we are going to discuss PLL operation, block description, the monolithic PLL IC and the VCO IC and its principle of operation. Start the PLL block description. PLL is a phase lock loop. It is a fundamental feedback control circuit that generates an output signal whose phase and frequency matches with the input reference signal. It consists of a blocks, phase detector, low pass filter, and voltage control oscillator. The PLL are widely used in communication systems, FM demodulation, and clock generation. It is the block description of PLL. PLL consists of a traffic detector. It compares the phase and frequency of the input signal with the output of the input oscillator. It generates an error voltage that represents the difference between the two. The sum and difference component are passed to the low pass filter. The low pass filter removes the high frequency component and it passes only the difference in frequency component. The VCO generates the frequency voltage applied at the input phase detector to repeat the cycle until the frequency signal is equal to the oscillator frequency or the difference becomes minimum. At this condition, the feedback loop locks the output frequency with the input signal. Capture range and lock range is defined as given below. Lock range is otherwise called as tracking range. It is nothing but the range of frequencies over which the PLL can maintain a locked state with the input signal. The capture range is defined as the range of input frequencies over which the PLL can initially acquire or lock onto the input signal from an unlocked state. Next, we'll discuss the monolithic PLL IC 565. IC 565 is a popular monolithic PLL IC. It contains phase detector and an VCO internally. The operating voltage range is typically plus or minus 5 volts to plus or minus 12 volts. The application includes frequency multiplication and FM demodulation. It is a 14-pin IC which consists of VCC and ground, and two input signals are given to the 2-pin, and you have an VCO output pin and an phase comparator output pin. You have a modulating input signal and demodulating output which can be taken if required, and two pins are allowed for external timing component to be connected, which is capacitor and resistor. As shown in the block diagram given, it consists of the block, phase detector, amplifier, and VCO. The low pass filter is constructed using resistor and capacitor, which is shown. Phase detector compares the phase and frequency of the input signal through the 2-pin 213, and the amplifier amplifies the output of the phase detector and it is given to the low pass filter, which is constructed using resistor 3.6K and capacitor C2. The low pass filter removes high frequency noise and AC component from the error voltage. And next block at the feedback is given is VCO voltage control oscillator, and external timing component RT and CT are also connected, in which you can take the output from pin number 8 and 9. It generates a square wave output frequency at pin 4 that is proportional to the input DC control voltage. Thus, this is the block description of your IC 565 PLL IC. we will discuss the VCO monolithic IC operation, the IC566. It consists of a constant current source, a schematic trigger, and two buffer amplifiers working together to generate a simultaneous square wave and triangular wave output. The output frequency changes according to the input control voltage. Higher control voltage increases the oscillation frequency. VCOs are used in PLL systems, modulation, and signal generator. It is an 8-pin IC in which you have ground and power supply connection and one input modulation input and timing components R1 and C1 in pin number 6 and 7 and pin number 3 and 4 we can take the output. The inner functional diagram is given as in the block diagram. It consists of a constant current source, a schematic trigger and buffer amplifier. The constant current source controls the linear rate of charging and discharging the external timing capacitor C1 connected at pin number 7. The value of the current is set by external timing resistor R1 at pin 6 and the modulation control voltage VC at pin 5. The schematic trigger acts as an automated switch. When the voltage across C1 hits the upper threshold, the trigger flips states to reverse the current source, causing the capacitor to discharge linearly. When it hits the lower threshold, it flips back to charge it. This continuous flipping outputs a high quality square wave. Buffer amplifiers isolate the sensitive inner relaxation oscillator component from external load. The buffer on pin 4 outputs the linear voltage ramp of the capacitor as a triangular wave. Thus, the frequency of VCO is derived as using the VCO IC F0 in terms of the control voltage. The voltage to transfer frequency transfer coefficient is the gain of the VCO. Thus, we have discussed PLL operations in this lecture. Thank you.